what is our promise? Well, early on, we made a promise to each other that during our Zoom calls, we would participate. Yeah, that means don't just sit there and do nothing. Be respectful. Don't talk over people. Be nice. Be kind. O is for on time. Thank you for that. M means stay muted. I know it's hard, but please do that for me. It's a huge favor. Oh, I hear somebody unmute. Wait a minute.
This is CJ's mom. CJ said you want to talk to me.
Everything okay?
Oh, he said you want to talk to me?
Oh, no. I was
Okay,
just saying, I'm
sorry.
sorry. I was just saying that we need to stay muted, and if you have a concern, to text me. That's all.
Okay. All right.
I'm sorry.
It's okay.
All right, guys. And then I is change your name in the chat or in the Zoom if you can. If you can't, don't worry about it. S is for stay seated, unless I tell you to get up and move around. And E is for keep your eyes on me. Keep your eyes on the screen. There's going to be a lot happening. Now, what are we doing today? Today, we will model problems using drawings or objects again, so we can represent and solve an addition, more, plus, or subtraction. Bye-bye, no more. Take away. I know I have it when I can use models to solve an addition or a subtraction problem. Next steps, I will be able to choose the most efficient model or strategy to solve a problem accurately. Accurately means correctly. Efficient means quickly and correctly. Okay, we need to be able to do things the right way as fast as we can. Now, we have a quick review. How fast are you? In this review, I'll open it just a little bit bigger. You'll notice 4 problems, and they already have models. Look how easy we made this for you. The models are already drawn. My personal opinion about the models are I prefer dots because it's so hard to draw little airplanes and so many of them. So in my opinion, this would be silly on a test. Just use dots, okay? You heard me say it. I'll say it again. Don't draw complicated drawings in your models, just draw dots. All right, but you can go ahead and solve the math problems. The first one says 4 plus 2. A word problem might sound like there were 4 airplanes flying in the air and 2 more came to join them. How many do we have now? Total. And then look at that, they flip the numbers around. Oh, those tricky guys. Instead of 4 plus 2, they flipped the addends. Remember, they're called addends. And instead of 4 plus 2, it's now 2 plus 4. That would be like if you're, I don't know, let's see, you would be sitting with a friend and then you switch places. How easy is that? That's called a fact family. And then at the bottom, we have 2 more. The sum equals 3 plus 6. And then look what they did. They flipped it around. Instead of 3 plus 6, they now have 6 plus 3. All right, Miss Cruz, let's see what we have going on. Oh, look at Larissa's. Beautiful, I like her sums. That tells me you know how to count. Count on, add your models. Here is Jaden's. Whoa, look, I see something a little different here. Can you guys see this right here? Jaden, your sum came first in this problem. Isn't that weird? That they made the equal sign in the beginning. Oh, so the sum is the total. And you're saying that 3 equals 3 plus 6. But does 3 plus 6, the sum of those 2 trains, those addends, does that actually total up to 3? Just because we move, you can change it. Just because we move where the sum goes, I mean, I can put it on the ceiling. It doesn't matter. I could put it on the floor. I can put it in Walter's back pocket. Yeah, I could put it anywhere. But the sum is always going to be the total of the 2 addends. Doesn't matter where I put it. All right, let's look at Benito's. All right, Benito, you can change yours too. See this 3 right here by the trains? He's doing it right now. 3 plus 6. That is the addends. We want to total them up and then put the total amount in that sum. And 6 plus 3 can't still equal 3. If you had $6 and I gave you 3 more, got to be more than that. Thank you for changing that. Let's see, who's this? Manasvi. Oh, look at that. Yes, no matter where I put the sum, doesn't matter where I put it, it's still going to be the total of all of the addends. Got it? Get it? Good. Here we go. All right, puppies, let's try something else. You're awesome. Here it comes. Uh-oh, somebody, it's okay. I can't look at everybody's, you know. Did we get rid of? I think we got rid of it. Yeah, let's look at something else. Now, this looks very familiar. Oh, look at these. What does crossing out mean? Oh, who knows it? Larissa, what does it mean?
And when you cross out, that means you take away.
Yes, and what's the big word? It starts with an S.
Minus.
Subtract. Yes, excellent. Woo! Someone helped you. I heard that. I love that help. Thank you. All right, mute. You're wonderful. Oh, thank you. Yes, when you see a model and it's crossing some out, it means they're taken away. And the symbol is the minus sign. See that little dash, that symbol? That's the minus. And then that all means that we are subtracting. It's the opposite of addition. Did you guys go ahead and write in your, oh, it's not called a sum anymore. Oh, it's a new word. It's called the difference. It's not the sum, because sum is when you add. Oh, turn to your, I don't know, turn to your person next to you, somebody in the room, and yell out this word. Are you ready? Difference. Thank you. They're going to say, what? Yeah, the difference is when it's the answer when you subtract. It's not called the sum anymore. It's called the difference. Thank you. All right, let's look at a couple. I can only look at a couple. Let's look at Aditya's. Oh, yes, excellent. So it told you what to do. It said, yo, there's 8 boats and I need you to cross out 6 and then tell me what the difference is. Okay. Yes, and look at our answer here is 2 left. Wonderful. Let's look at Yalini. Let's look at Yalini's. Oh, yep, she followed the directions. Your parents must love you guys because you follow directions. Yeah, it said, excuse me, take 8 boats and cross out 6 of them and write how many are left. And you did it. Nice job. All right, let's look at Walter's. Where's Walter? I saw him. Where did he go? Here he is. Beautiful. Oh, he even typed his answer in. If you're unable to cross it out, I know that sometimes we can't cross it out, but I love it, Walter. Beautiful job. And one more. Siddharth. Let's look at Siddharth's. Look at that. Oh, he really X'd him out. That's beautiful. Excellent job, guys. Moving on. That was a quick review. We're going to watch a quick video. And this video is going to talk about a new strategy. Dun, dun, dun. What's a strategy? It's a way to solve a problem. All right. So let's say Francis is lost on an island in the middle of the ocean, and he needs to get home before dinner. His strategy, he's got to come up with a plan, man. So he has to figure out a strategy, a plan to get him home in time for his favorite dinner. Well, when you have a math problem, you have to think of the best strategy. What will get me to solve this problem the best? So we're learning a new strategy. Pay attention. I'm going to share my sound, and here we go.
Hello and welcome to Tutoring Hour. In this video, we'll show you how to use a number line to subtract numbers within 20. Buckle up to hop your way with Skittles and Snowball. Our first problem is 5 minus 3. We have our number line and Skittles, our little birdie, perched on the number 5. She needs to hop backward thrice. 1, 2, and 3. Now Skittles is on the number 2. So 5 minus 3 is 2. Good going. Let's move on to our next problem. 9 minus 4. We'll bring our number line. We have Mr. Snowball on the number 9. He needs to hop backward 4 times. 1, 2, 3, and 4. Mr. Snowball has landed on the number 5, and that is our answer. Now let's find the difference between 15 and 8.
The difference.
Here is our number line. It doesn't have the number 15. Let's extend our number line to
Ooh,
20.
we made it bigger.
Now we'll start with 15 and draw 8 hops backward. 1, 2, 3, 4, 5, 6, 7, and 8.
Stop right there. Raise your hand if you have ever used a number line in your life. Yes! Raise your hand if you know that your number line can start anywhere. Oh, don't unmute, don't unmute. Oops, don't unmute. Oh, don't unmute. Okay, thank you. Raise your hand, put your hand down. Give me one finger if you know that your number line can start on any number, but these start on 0. Right, and now raise 2 fingers up if you understand that if you hop one way, you're adding, and if you go the other direction, you're actually subtracting. Yeah, you're doing the opposite. So notice that when we are taking away, bye-bye, we are subtracting, and the hops, the little bunny rabbit was hopping backwards, down towards 0. Oh, Miss Cruz, I get it now. Okay, let's
We
find
have
the rest
landed
of
at
it.
7.
We're going to try this out on our
15
own.
minus 8 is 7. That was pretty quick.
Here's the difference. Okay, you guys ready to try it? Here is the example one more time. This one you can't draw on. I just want to show you. We started at the 7. Put your little finger on the green dot. You start at 7, and we take away 2 hops. You're a bunny rabbit now. Don't unmute. You're a bunny rabbit, and you're going to jump. And make sure you jump on each number. Don't jump in the middle of the number. There's nothing there. Hop on the 6, and then one more time to take away 2 jumps. Okay, you guys ready to try it? Let's do it. There are 3 examples right here. Siddharth, I'll get to you in 2 seconds. 3 examples right here. It says 5. So go to the 5, jump on, go sit on the 5. And then it says to take away, which means, remember your bunny rabbit? Hop backwards 4 jumps. What do you land on? That's your difference. Oh, I love number lines. Do the same thing for 8 minus 2. Go to the 8, hop backwards 2, take away 2 jumps, and then try the last one. Start on 4, hop backwards 3. What do you land on? That's your difference. That's the answer. Okay, Siddharth, go ahead and tell me what you were going to say.
Can we do the climb birth today?
Not today. We're going to do most of our game. I think I don't have a time to climb. Actually, I don't know. We might, but we'll have most of our games tomorrow, okay?
Okay.
Okay. We'll have a lot of games tomorrow. You'll need an extra 5 minutes, and I'll tell you what exactly you'll need, okay? Go ahead and do your math lesson today by jumping backwards. This is a new strategy, guys. Using a number line is a strategy that many people use. Some mistakes kids make. Let me tell you about the boo-boos I've seen over the years, okay? Yeah, I've seen some mistakes. Some mistakes are they don't jump on the lines. They jump in the middle of the lines. Now, why would we do that? I don't know why. So you have to make sure that you jump on each line, which represents a number, okay? And then sometimes they don't check to see how many jumps they make. So it says jump backwards 4, but oops, they jump backwards only 3. Ooh. So you have to do exactly what the directions say. Remember, listen to your mama. Listen to the problem. Jump exactly what they say. Okay, let's look at 5 people fast as I can. And it's okay if we don't get to everybody's. You know that. Let's look at Blake's. Ooh, Blake. All right, let's see. It's hard to draw on this. I know it's kind of hard. You are to start on 4 and jump backwards 3 jumps. So here's my 4. I'm going to go 1, 2, 3. I land on the 1, and hopefully you will write your difference if you can right there. Thank you, my love. Let's look at Arush. Very nice. Now, let's look at this one right up here. It says start on 8 and jump backwards 2. Remember that bunny rabbit? If we're taking away, the numbers are going to get smaller. That's right. So we're going to go backwards. We're not adding up. We're going and subtracting down. And I love it. He went backwards 2 and landed on 6. Okay, 3 more folks. Let's look at, somebody's unmuted and I've asked, don't unmute. We'll find out who it is. I'm going to eat them for dinner. Okay, let's see. Almo, let's look at Almo's. Almo, you have to just draw on the lines if you can. So here you would put a dot on 5 and then jump backwards 1, 2, 3, 4 little hops. You can draw those hops like little humps. Let's look at, let's look at, who's this? Oh, Johnny's in progress. She's not done yet. Yalini, let's look at, oh, she's so fast. Oh my goodness. Yes. Well, let's try this one over again. This one says to start on the 8. When you subtract, you always want to go to the biggest number, don't you? I mean, you can't start with a 2 and try to give away 8. You won't have enough. So start way up here on the 8 and then jump backwards 2. Try that. That would be following the directions perfectly, okay? And let's look at Larissa's. Oh, yeah, I like this. Very nice. Yes. Oops. Let's look at this one. You went 1 too many and landed on 0. Even though your answer said 1, you made your hops.
Yeah. I noticed.
It's okay. It's okay. You're awesome. Don't unmute. Wonderful job. Okay, let's go and look at one more kid. Brooklyn. Ooh, Brooklyn's going to try hopping. But look at all our answers. Let's look at this one again, because this one I'm not sure I can read this answer. Is it a 6 or is it an 8? Could be both, right? So we'll have to figure that out. But if you start on 8 and you jump back 2, 1, 2, you land on a 6. Okay. Number lines are one of my favorite strategies. If you have time to draw one, if you have a number line available, and I saw a ruler that looked like a number line. It was so cool. So having a ruler handy is very nice. Okay, moving on fast. We have a lot to do. Okay.
Jack Cartman.
Kids Music Channel.
More about number lines. Oh, number bonds. Stop, Miss Bruce. Okay. Once upon a time, I told you that I was going to fill your head with strategies, ways to solve problems, right? Do you remember I said that? Oh, okay, good. Here comes a new one. This is called number bonds. So today you're going to learn 2 new strategies. That's right, not 1, but 2. 2 for the price of 1. Wow, it's like a sale. So you guys are learning not only how to use a number line for addition, counting up, and subtraction, counting down, but now we're going to learn about number bonds. It's in your lessons, so pay attention.
Number bonds, that make 10. I know my number bonds, they help my math stay strong. 2 parts make a whole, let's move and sing along. Right arm up for the 1 part, left arm up for the other part, both arms up for the whole. Let's go! 0 plus 10 makes 10. 1 plus 9 makes 10. 2 plus 8 makes...
Oh, I'm going to stop there. What do you guys think it is? Anybody? Siddharth. If I have 1 part is 2 and the other part is 8, what would that total be? The
10.
sum? 10, that's right.
Because 8, we have 8. Then we went to the market and buy 2. Then we have 10.
I love that word problem. Nice job. Guys, the total is 10.
Makes 10.
Break it apart, put up 10 fingers. give 2 to your friends, and the other part goes to you. That's 8. Oh, it's like breaking the whole thing up into 2 different parts. I get it now, Miss Cruz.
3 plus 7 makes 10.
Notice the addition.
4 plus 6 makes 10.
You're adding.
5 plus 5 makes 10.
You knew that.
6 plus 4 makes 10.
Wow.
7 plus 3 makes 10.
Those sound like a bunch of ways to make 10,
8 plus 2 makes 10.
but you can make number bonds with
9
anything.
plus 1 makes 10.
Any sum.
10 plus 0 makes 10. Those are the number bonds that make 10. 0 plus 10 makes 10. 1 plus 9 makes 10.
Okay. I'm not going to go through it all again. What I am going to say to you is, well, Mrs. Cruz, I understand why we'd want to use number lines. I get that. It's easier for us to figure out an easy math problem because we can hop up and down. Yeah, I get that. Why are we learning number bonds? Dun, dun, dun. There's a reason. I heard 2 of my students in their lesson, their work that they submitted, listen. They talked about how they could solve for unknown parts. Yes. So if you have a problem, and let's say that Christopher, don't unmute, but let's say that Christopher said, I have 3 and I need to know how many more I need to make 10. So I'm missing a part. I have 3, but I need all 10. What's that missing part? Number bonds help with missing parts. They also help with subtraction. So let's, I see some hands up. Okay, hold on tight. So we're going to learn how we can use the different parts of an equation, the sum, the whole, and then break it into 2 parts. Now let's look at the pie right here. We have a whole pie, and they said, okay, well, I'm going to give this one part over here to Olmo, and the other part will go to Benito. I'm going to break my pie into 2 parts. And if I add those 2 parts together again, Benito and Olmo's part, it makes the whole. It comes back together as the whole. And if we use numbers instead of pieces of pie, well, because it's math, right? So 10 minus 4, if I had the whole thing as 10 and I gave Olmo this part, Benito would have this part. If I added them back together, Benito's part plus Olmo's part, and the whole goes back together. All right, so can we skip this real quick? Thank you. All right, you guys are going to start working on this while I talk to the folks that raised their hand. This is addition facts to solve subtraction. Remember I said it was helpful for subtraction? Well, it is. It's also great for unknown parts. If you know the parts and you know the whole thing, you can fill in the missing numbers in the equation. Let's say that Blake noticed that 7 is the total and we broke it into 2 parts. 5 is one part and 2 is the other part. Look at that subtraction equation. We can plug in the numbers since we already know the number bond numbers. 7, take away the first part. Let's take away 2. And then what would be left over? What's the other part? It's already there. I can see it with my eyeballs. Can you see it, guys? Can you? Can you really see it? Can Precious see it? Yeah? Awesome. 7 minus 5 equals 2. So I can plug those numbers right in. You may do all 3. And let me see who is raising their hand. I don't remember who was raising. Oh, Siddharth, did you have a question? I see your hand right here. So, Siddharth, do you have a question
Can
for
I
me?
show you something in the end of the class?
Yes. Yes, at the very end. Thank you for asking. How about London? London, you have a question?
Yes, I'm not able to do the question, and I'm not able to do the thing, the math.
I understand. Don't worry about it. I will post your Nearpod later for your parents and they can open it up and hopefully you can practice it later, okay? You can also do this on a piece of paper. Totally. You can just copy it on paper. It's all fine. No worries. Okay. Now let's see. Christopher, you have a question?
Teacher, I'm almost done.
No. Why? Don't leave me. Be respectful, sir. Let's keep going. All right, let's look at Aditya's. Oh, wonderful job. If I can't get to everybody's question, I'm sorry. But let's keep moving on. Yes, look at Aditya's problem. She knew that the number bond already has all the numbers you need, the total sum and the two parts it was broken into. Do you know what a great activity for you to try making number bonds is? Getting some cubes. Yes, get a stack of cubes, put them together, and then break them apart and into two different parts. So if you have 10 cubes and you closed your eyes and broke it at a certain point, and then you opened your eyes and said, "Ooh, I've got 4 in one part and 6 in the other part. That's my number bond. 4 and 6 equals 10. It's 3 numbers, isn't it? Anybody notice it's 3 numbers, your total, and then broken it off and up into 2 parts? Wonderful job, Aditya. I'm going to look at, let's look at 2 more folks. Let's look at, who is this? Johnny. Okay, look at Johnny. She also, you know what's cool is there are no strangers. She didn't put in some strange number in. Look at this one right here. 4 minus 3 equals 1 matches the number bond numbers. She didn't sneak in some strange number like 5. He's not in this number bond. That's right. So she was using the number bond numbers to plug them in to a subtraction matching equation. Fabulous, Johnny. Let's look at Siddharth's. Yes, same. Love it. Also love the fact that you know that when you subtract, you start with a big, rich number. When you give away, you have to start with the biggest number you have, right? You have to be rich in order to give stuff away. So you have to start with the biggest number you have. Wonderful job. Let's look at Francis. Yes, excellent. Francis, I love your answers. Beautiful. You're so brilliant. Love it, love it, love it. Okay, let's move on. I know some of us want to be done, and I get it. We're getting close to the end, and I want to tell you a secret about tomorrow, okay? All right, you only have time to do one problem. Pick one. Only pick one. Look at the number bond. Did you notice that some of the parts or the sum is missing? How in the world are we going to, it was easy on the last slide because the number bond was already filled in. It was done. It had the sum and it had both parts. But look at this. We have missing parts, or in this case, a missing sum. Can you figure out what goes in there? I think you can. What did Mr. Jack Hartman say? 5 plus 3 equals, And what would we do if we were missing a part? Oh, okay. So think about what strategy we would use to find the missing parts. It's okay. No worries. All right. Yep. So this is great practice for you and your families to work on, creating number bonds, finding out the missing parts in a number bond, and then writing some really cool equations using the number bonds. And make sure those equations make sense. You know, one time I wrote the silliest equation. You want to hear what it was? Don't laugh. Okay, you can laugh a little bit. It said 5 minus 10 equals 0. What? That was silly. 5 take away 10, and I have not, that doesn't even make sense, Miss Cruz. You're talking alien. So yeah, make sure that your equations aren't ridiculous. So here, if I said 8 minus 8 equals 3, that wouldn't even make sense. Besides, I have to use the numbers from the bonds. Okay, let's just look at you were supposed to just pick one. Ooh, look at Siddharth. He picked all 3. He was ready. Wow. Nice work. Yes. Okay, Siddharth, you can unmute. Tell me, how did you find the missing part for 5, 4, and 1? How did you figure out the missing part was 1?
4 plus which number equals 5, 1.
That's right. So you just had to find what would add up to make 5 the total. So you realize that just 1 was missing for you to make the number bond whole or complete. Same for 4 plus something equals 6. 4, 5, 6. Oh, it's 2 more. Ah, very nice. Love it. Okay, quick, let's look at Francis. Yes, fabulous. Also, Francis, you're brilliant. You know that you need to start with the biggest, richest number you have if you are going to subtract. Don't start with a tiny number. You can't give away if you start with the smallest number. And let's look at Jaden. Jaden, you rock. Awesome. Look at that. 6 take away 4 equals 2. He understands the number bond. Let's move on fast. We got to get to the good part. I need to hear from 2 people today. 2. So I'm going to see who I land on when I close my eyes and point to a face. I'm going to point to a face over there. Your faces are over there. And I'm going to point, and you're going to help me by discussing, how do we know that a strategy is efficient? Remember my big word? Efficient. So that's the first question. Anybody want to answer that? How do you know if the strategy you choose is efficient? Okay, here it comes. Who's that? I see. What do I see? I see Brooklyn. Brooklyn, how do you know if a strategy is efficient? What does it have to be?
I wasn't raising my hand.
I'll help you. Do you want some help? I would love to hear your voice. Remember when I talked about efficient means you have to do something really fast. Go ahead and tell me. Super fast.
Fast?
Yes. Excellent. I love you. You can walk around using the word efficient now because it means to do something fast. And who else knows it? Olmo, do you know the answer? It also has to be something else. Correct. Is Olmo here? Oh, let me go with Larissa. It has to be fast and it has to be
Correct?
Yes, that's right. So you and Brooklyn make a fine team. Yay. Yes, you guys can walk around saying, is that efficient? Is that efficient? Is it fast and correct?
At the end, can I talk to Brooklyn?
Just a minute. Okay. So, and my second question, Siddharth, I pointed to you. How do you know you chose the best strategy? So let's say you were solving a problem, 18 minus 12, but you decided to use dots and drew dots. Is that the best strategy? Is there a different strategy you should have used or could have used? How do you even, okay, how do you know if you choose the best strategy? What has to happen?
It has to be correct.
That's right. And fast, it has to be efficient. So if you choose, let me give you an example. This is so silly. You want to hear this one too? This really happened. Okay, I had a student and they were solving the problem. I promise this is true. 186 minus 90, right? So Guess what they did? They drew 186 dots. Yeah. And then they tried to cross out 90 dots. Do you think that would take a long time?
Yeah.
It would take forever, wouldn't it? What if you didn't count them right? And then you have to do it all over again. Was that the most efficient strategy, Siddharth?
No.
No, could you think of a better one?
Which equation was it? 100 minus 90?
Yeah. Could you think of a better strategy? Something else that might help?
90 plus which number equals 100?
Yeah, you could count up. Absolutely. All right. So, guys, what I needed to discuss with you is we have a whole bunch of strategies. We need to know which one works the best. That's really what it is. So out of all the strategies that you have learned so far, and I will remind you of what they are, which one has helped you solve problems the best? Let's try looking at the answers. Do you like doubles? How about number line? How about the number bond? We just figured out that one. How about tens frames? How about drawing models? There's a lot of strategies, and there's more to come. We are going to learn so many strategies. Francis will never be stuck on that island. He will know exactly how to get home, solving a math problem the fastest, most efficient way. Fabulous, guys. If you don't have an answer yet, don't worry, because you're going to learn more strategies, and you can choose strategies based on the problem. Not all strategies work for all problems. You know that, right? Okay. So we are done for today. Aren't you excited? We're a little late, but I have some things to share with you, okay? So I'm going to stop sharing and look at your cute faces. Hi. Now, you're my mathematicians, okay? You're spectacular at solving math problems. Make sure you're trying to do it without your parents' help, okay? So I need to know what you know, not what your parent knows. And when you are solving, it's okay to ask them questions, but make sure that you are trying to solve it on your own. Don't ask them for help all the time. Now, the other thing I want to tell you about tomorrow, real quick, before I let anyone talk, is we are going to play a Kahoot game. We're also going to play a silly game. Make sure you have socks. Yeah. We're going to try something fun with socks. Okay. So make sure you have a pair of socks ready to go. One pair socks. Okay, we're going to play a little game. And then what else do we want to do? And then we have we're going to watch a video. Remember we were talking about growth mindset. We're going to add that in too. Okay. You guys are amazing. Does anybody have any questions?